Ever notice your Flutter app freezing when parsing JSON? That's because most devs use JSON.decode in the main isolate, blocking the UI thread. Let's look at this common but terrible approach. We're using the standard HTTP package for all examples. In this bad implementation, after getting the response from the API, we call JSON.decode directly within our fetchUsers function. This approach is slow, leads to a bad user experience, and introduces major issues. It blocks the UI thread, relies on unsafe dynamic types instead of proper models, and has no proper error handling. We need a fix, and that fix starts with isolates. The first major performance leap is to move that heavy lifting, the JSON parsing, to a background isolate. We do this easily in Flutter using the compute function from Flutter Foundation. First, we introduce a strongly typed user model with a from.json factory. This immediately gives us type safety and is crucial for the next step. We wrap the parsing logic in a static function, parse users in background, and pass body string to it using compute. This offloads the slow JSON.decode operation to another CPU core, completely freeing up the main isolate to keep the UI smooth. Beyond the speed boost, this optimized code includes error handling with a try-catch block, a timeout on the network request, and a mounted check to prevent calling setState after the widget is disposed. This is the minimum standard for robust API calls. If you want maximum performance and boilerplate reduction, you need code generation. This is the best practice for real-world Flutter apps. We use JSON annotation and JSON serializable paired with build runner. First, we add dependencies to pubspec.yaml. After adding the dev dependencies, we define our models like user and its nested address by annotating them with JSON serializable. Then, we run the code generator command in the terminal. This command generates the boilerplate from JSON and to JSON methods for us. The generated code is highly optimized, making the parsing process 2 to 3 times faster than even the manual implementation with compute. Now we can use our generated models with compute for the fastest, safest, and most compile time checked parsing available. Performance benefits: 2 to 3 times faster parsing than manual implementation. Compile time safety, catches errors early. Supports nested objects automatically, and less boilerplate code. Even with the fastest parsing, loading a massive dataset of thousands of items at once will always be slow and use too much memory. The solution is pagination and infinite scroll. In this example, we've modified our API call to request only 10 users at a time, using the skip and limit URL parameters. We manage the state with a page counter, an isLoading flag, and a hasMore flag. We attach a scroll controller to our listView.builder. When the user scrolls to the bottom, when the current scroll position equals the maximum scroll extent, we automatically call fetchUsers to load the next page. This gives the user a seamless, modern, infinite scroll experience without the initial lag of loading everything. Key features in this example: infinite scroll, loads more data as user scrolls. Page tracking, only requests needed data. Loading states, shows progress indicator. Memory efficient, doesn't load all data at once. Error resilient, handles failed requests gracefully. Finally, to make your app robust and blazing fast on subsequent loads, we need smart API caching. This is where we bring in local persistence using the Drift package, a powerful SQLite library. Add Drift dependencies to pubspec.yaml. We add Drift's core and build dependencies along with path and path provider to locate the database file on the user's device. In our database.dart file, we define the user's table structure, including a cached@at timestamp. In our API service, we implement a simple cache-first strategy. Just like with JSON serializable, we must run the code generator to build our database helpers. Before making a network request, we check the database with db.cachefresh. This query looks at the timestamp of the latest entry. If the data is fresh, less than 5 minutes old, we immediately return the data from the database. This gives an instantaneous load for the user. If the cache is stale or empty, we fetch the new data, clear the old cache, and insert the fresh data with the new timestamp. This provides great offline support and ensures your users aren't waiting for the same data to download repeatedly. In the app's UI, the User List screen calls Load Users on Initialization. This function uses our API service to try the cache first. Notice the Refresh button in the app bar. It calls Load Users Force Refresh True, bypassing the cache check to guarantee the latest data from the server. This setup gives us maximum control, great offline support, and superior performance. Key takeaways. To summarize how to supercharge your data handling in Flutter. Never parse JSON on the main thread. Always use compute or isolates. Use JSON serializable for the fastest, most type-safe models. Implement pagination for large data sets. Use a package like Drift to cache API responses for offline support and faster loads. Always use strongly typed models instead of dynamic. Don't forget robust error handling and the essential mounted check. Now your API calls will be blazing fast and your app will never freeze during data loading. Implement these techniques into your project and see the difference. Let me know in the comments below, how much faster did your app get after trying these techniques?